Okay, this is the calculator paper, non-calculator paper, sorry, for the higher. It's the grit paper 2. It's the second one on the run up to the second lot of PPEs. Okay, and we'll just see what we've got then. So we have a scatter graph. I'm just going to quickly read through the question. In the question, it doesn't say anything about plotting coordinates, so straight away I'm going to draw a line of best fit just so I don't forget to do that. Line of best fit, you can tell I've got in the same direction roughly. I've gone roughly in the middle of the coordinates, and that'll do. Okay, so there's line of best fit done. It doesn't actually ask me to do that at any point, but I think it's important. When I describe the relationship on a scatter graph, it's to do whether it's a positive correlation or a negative correlation. This one is a positive correlation, and it's only one mark, that probably would do. But because it's talking to me about pretty much saying describe the relationship between hand length and foot length, I'm going to talk about them specifically. So with a positive correlation, as one gets bigger, so does the other. So as the hand length gets bigger, so does the foot length. So the bigger foot length, the bigger the hand length. If it was negative, it would be the reverse. So the bigger the foot length, the smaller the hand length, which obviously wouldn't work. Next bit, Toby has a hand length of 18.5 centimetres. It says hand length there, so I know I'm going from this way. I'm going from this axis, and it's from 18.5, so I'm going to draw a line from that. This is the reason we had the line of best fit in the first place, okay? And I expect to see these lines of best fits, and the rest of the staff expect to see them, because we're just not going to give you the marks, okay? Although I think in the real exam you will be given them. That's gone here. This is going up in squares of 5 for one whole unit, so that means it's going up in 0.2s. Okay, so that will be 24.2. Okay, nice and straightforward. If you see a scatter graph on the exam, it's a nice little winner of marks, nice and straightforward. Okay, so standard form. Standard form is nice and straightforward when you know what to do, obviously. The first question is just a simple conversion, so write as an ordinary number. Now, if it's got a negative power, that does mean it's going to be a decimal. Okay, so it's going to be a small number. That means I know which way, really, that this decimal point is going to shift. It's going to go 4 places that way. So then I fill the rest in with zeros like that. So 0.00023. That's it as a standard number, an ordinary number. The next one is kind of the same, really. It's just asking you to use it a little bit differently. It's not asking you to do any calculations with it, which it could do. It's just asking you to put them in order. So this is in standard form, and it's not a decimal. It's not a decimal because it's a positive power. So this is a big number. And what we need to do is get them all in the same format. So I'm going to get them all in the format of just a standard value, an ordinary number. So 5.86 times 10 to the 6 means I'm going to move this decimal place to the right because it's going to be a big number. 6 places. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There. Get rid of that. And that means it's going to be 586 with 1, 2, 3, 4 zeros. Okay, so that's that converted. So I can compare it to B already, and you can tell city A is bigger than that. Million. A normal million is 1 with 6 zeros. So if you're not sure, that's kind of how it looks. So this will be 5, 3 with the rest of it filled out to the same size. So you've got a 7-figure number, really. Now I can compare them. City A has the highest population first, so A is going to go down first. Next is C, and the next one is B. Okay, because you can tell by lining them up. If you really wasn't sure, you could write them right on top of each other, and then you could really compare them properly. And then you could probably see which one's the biggest from this value, and then so on and so on. Okay. Right, next one. Transformations. Translation is nice and straightforward. It's something to know about this bit. If you draw your arrows this way and this way, so your left and your right and your up and your down, you can see that we're going to go left 3 and down 1. Okay, so if you don't do it the right way, it will just be wrong. You'll just go the wrong way. So choose a corner. and move that 3 places to left. 1, 2, 3. Check your scales in ones. If it's not in ones, you have to make sure you're doing the right amount of jumps. And then down 1. So that top corner is going to go right there. So then I'm going to draw the shape. You should be using a ruler. Just use the edge of this. There you go. Just make it a little bit smarter. And sometimes it says label it or whatever. Okay, so I'm going to label it B just in case. Because this question's a little bit dodgy. I don't think they've written it properly. Okay, so that's the translation. Just moves from side to side, up and down. Just gets moved around. Now this one hasn't been done properly, and they've not changed the image on the higher one. So in my class, on the board, I drew this shape on for you. Put it there, and I got you to describe how it moves from here to here. And I suggested to you, I knew what they were trying to get you to do because it was a 3-mark question. I knew that it was going to be a rotation. I didn't tell you that, but I knew there was only going to be one that we're looking for. So I'm going to write down rotation. And then I'm going to say the angle is upside down, so it's gone 180 degrees. I don't have to use clockwise or anti-clockwise because it doesn't matter on 180 degrees, but if it was 90, I'd have to say which direction. And then I need to choose the center of rotation. When it's 180 degrees, there's a nice trick of just connecting the corners in pairs and it'll overlap on the center of rotation, so that is 0, 1. Sometimes when it's 90 degrees or 180 degrees, you'd have to draw on both shapes and test the coordinates on tracing paper. So you would test the coordinate and see if it moves to it or not. Okay, so that's how you do that one. Right, question 4. Nice little awkward question, and there's a few ways to tackle it, so it just depends on your teacher's preference and how they want to do it. So Tina's going to drive from London to the French town of Lille. Tina will drive from London to Dover. She'll get on a ferry from Dover to Calais. She'll then drive from Calais to Lille. The distance from London to Dover is 80 miles. The distance from Calais to Lille is 120 kilometres. So these have got to be they've either got to be all turned to miles or they're all turned to kilometres. We have to do something about that. She has fuel for it to drive 150 miles. Now, because this is in miles, I'm going to turn this one into miles as well. And then when it's all in the same units, the question becomes easier. So she can only afford to do 150 miles, and I need to see if she's going to travel more than that. And if she does travel more than that, she cannot. She doesn't have enough fuel. So I'm going to turn 120 kilometres into miles. That's my objective now. So I know that 5 miles equals 8 kilometres. And this has been turned into 120. All right, so I need to decide what that's been multiplied by, and then I'll do the same to this. So the way to do that is actually to divide 120 by 8. 8 into 1 goes 0, carry 1. 8 into 12 goes once, remainder 4. 8 into 40 go 5 times. So this has been multiplied by 15 to achieve that. So I'm going to do the same to this side. I'm going to times 5 by 15. So 15 times 5. 5 times 5 is 25, carry 2. 5 times 1 is 5, and that is 75. So 120 kilometres is actually 75 miles. And now I can use this in my calculation. She's got 80 miles from London to Dover. We've now converted this into 75 miles, so she's going to drive an extra 75 miles to make 155 miles. She can only do 150, so she does not have enough fuel. She does not have enough fuel. Okay, so a little bit tricky if you're not used to it. And I've set it up kind of like a proportion question or like a ratio question where one's been changed. There are many ways to do it. Like I say, it does depend on your teacher's preference. But I think that way is nice and clear, especially in a non-calculator one. In a calculator situation, I might do it slightly differently. Right, I've got to go to duty in 2 minutes. I'll see how far I can get with this one before I create a new video. Right, write down a class interval that contains the median area. So median is in the middle. So I need to calculate this bit. There are 30, that makes 11, that makes 24, 35. Okay, so I need to locate the median. So if I add 1 and halve it, that'll be 36 divided by 2, which means it's the 18th number in the table. This group takes me to the 4th, this group takes me to the 11th, this group takes me to the 20th number, so this is where the median lies. So the median is in this group. Okay, the next one, is probably I'm going to pause it. I've got to estimate the mean. Now this is the first time we've seen this on a non-calculate paper, and it is going to be a decimal solution, and we are going to have to calculate with decimals by multiplying decimals, dividing decimals, and so on. So you're going to have to wait to the next video or skip to the next video to see this part so I can explain it clearly.